Good morning, Tony and all. We learn about the fluid mechanics by J.M. Shivsagar, MIT, Aurangabad. Basics of fluid mechanics. So in this we'll first see learning objectives. In learning objectives, first learning objective is to understand the basics of fluid mechanics, and second learning objective of this topic is to recognize the various types of fluid solvents encountered in practice. In introduction, we must know what is the meaning of mechanics, what is the meaning of fluid mechanics, and what are the different branches of fluid mechanics which deals with the fluid either in rest or in motion. Mechanics, the word physical science that deals with the both stationary and moving bodies under the influence of forces. Statics, the branch of mechanics that deals with the bodies at rest, and dynamics is the branch that deals with the bodies in motion. So fluid mechanics can be defined as the science that deals with the behavior of fluid at rest or in motion, and the interaction of fluid with solids other than the boundaries. And the fluid dynamics, the fluid mechanics are also referred to as the dynamics by considering the fluid at rest or the spatial case of motion with zero velocity. There are other than that the different branches that are the hydrodynamics, the study of motion of fluid that can be approximated in incompressible such as liquid, especially water and gases at a low speed. Hydraulics, a subcategory of hydrodynamics which deals with the liquid flow in pipes and open channels. Gas dynamics deals with the flow of fluid that undergoes significant density changes, such as the flow of gases to nozzles at high speeds. Aerodynamics deals with the flow of gases, especially airborne bodies such as aircraft, rocket, and automobiles at high or low speed. And the last branch that can be hydrology deals with the naturally occurring fluids. What is fluid? Fluid is a substance in a liquid or gas phase. A solid can be resisted and applied shear stress by deforming. A fluid deforms continuously under the influence of shear stress, no matter how small. In solid, stresses are proportional to strain, but the fluid stress is proportional to strain rate. When a constant shear force is applied, a solid evenly stops deforming at some fixed strain angle, whereas a fluid never stops deforming at an approaches constant rate of strain. In a liquid, groups of molecules can be more relatively to each other, but the volume remains relatively constant because of the strong cohesive forces between the molecules. As a result, a liquid takes a shape of a container it is in, and it forms a free surface in a larger container in a gravitational fluid, or a gas expands until it encounters the wall of the container and fills the entire available space. Because the gas molecules are widely spaced and the cohesive forces between them are very small. Unlike the liquid, a gas in an open container cannot form a free surface. The difference that can be given between the solid, liquid, and gases that with respect to intermolecular bond are strongest in solids and weakest in gases. Solids, the molecules in a solid are arranged in a pattern that is repeated throughout. Liquid, in liquid, molecules can rotate, translate freely. In gases, the gas space, the molecules are far apart from each other and molecule ordering. Classification of fluid flows. It can be first classified as a viscous flow and inviscid flow regions. Viscous flow in which the frictional effects are significant. Inviscid flow regions. In many flow of practical interest, there are regions where the viscous forces are negligibly small compared to intertail pressure forces. Laminar flow is another flow, the highly ordered fluid motion characterized by the smooth layers of fluids. The flow of high viscosity fluid, such as oils or low velocities, typically laminar. Turbulent flow, the highly disordered fluid motion that typically occurs at a high velocity and is characterized by the velocity of fluctuations. The flow of low viscosity fluids such as air at high velocity is typically turbulent. Translational flows, a flow that alternates between the being laminar or turbulent. Force flow, a fluid is forced to flow over the surface or in a pipe by external means such as pump or fan. Natural flow, the fluid motion is due to natural means such as a buoyancy effect, which manifests itself as it rises a warmer fluid and the fall of cooler fluid. Thank you all participants. Thank you very much.